In this video, we'll look at the graphs of tangent, cotangent, secant, and cosecant. We'll start off by looking at the tangent function. This is the graph of the tangent function. Let's analyze it. Looking at the domain, all the possible x values, the graph covers all the x values except at these multiples of 3 pi over 2. So it's all the real numbers except the odd multiples of pi over 2. Think about why that is. What is tangent? Tangent is the y over x, and at pi over 2, x is equal to 0. So we'll have it undefined, or we'll have our asymptotes at y equals 0. The range, every single y is covered on that, so we'll go from negative infinity to infinity. That's part of the domain there. Continuous, each section is going to be continuous. So it's continuous on each interval. It is increasing on each interval. It is symmetric. It rotates in odd symmetry. It's symmetric around the origin. It is not bounded above or below. There are no local extrema. The asymptotes, we have no horizontal asymptotes. I'm going to clear this off a little bit. At the vertical asymptotes, we have vertical asymptotes at every point at k times pi over 2 if k is odd. So it has to do, it's the same idea we were talking about in the domain. We have the odd multiples of pi over 2. And the end behavior, if we look at the end behavior, is looking at what happens to the y as x goes towards infinity or negative infinity. If we look at each section here, as x is getting bigger, y is getting bigger to a certain point, and then it's going to jump. And so it's going to oscillate back and forth between infinity and negative infinity, going both directions. So the limits as x approaches infinity or negative infinity, the limits of tan x do not exist. Looking again at the asymptotes of the tangent function, if this is the cosine function, every place that the cosine is 0, the cosine corresponding to the x, when the x is 0, we have an asymptote. Every place the cosine is 0. Looking at the zeros of the tangent function, if we look this time at the sine function, red line here is the sine function. The sine function is dealing with the y value. Tangent is y over x. So when this numerator is 0, the tangent is going to be 0. So when the sine function is 0, tangent is going to be 0. This relates directly to the cotangent function. This is the cotangent. Cotangent is 1 over tangent, or the x over the y. Cotangent, when the y is a 0, is when we'll have the asymptotes. So here's the sine function, and when the sine function is at 0, we'll get our asymptotes on the cotangent, notice that the graph is going to be going decreasing on each section for the cotangent. And every place the sine is 0, we have our asymptotes. And if we look at the cosine, because the cotangent is the x over y, when the x is 0, the cotangent is 0. So when the cosine is 0, the cotangent will also be 0. Here we have the secant function, and the secant is 1 over the cosine. So if we look at the red dotted line here is the cosine. So on the secant, wherever the cosine is 0, we'll have asymptotes. Cosine is 0, we have an asymptote. And for the secant, when cosine is 1, we'll have 1 over 1, and the secant is 1. So when cosine is 1, the secant is 1. And if cosine was negative 1, that would make the secant 1 over negative 1 or negative 1. Here we have our cosecant, and cosecant is the 1 over the sine. So we'll start with the sine function here. Sine, with a sine, 1 over sine, when the sine is 0, we'll have our asymptotes. And very similar to the secant, when the sine is 1, cosecant will be 1. And if sine is negative 1, cosecant will be negative 1. So cosecant and secant, when we want to draw them, we can start very easily by drawing the sine function or the cosine function, finding the asymptotes, and then drawing our curves based on the sine and the cosine. Let's look at solving a trigonometric equation graphically. If we want to find the smallest possible number, x, such that x squared equals cosecant x, let's pull out the calculators and talk a little bit about graphing a trigonometric function. So let's look at some trig functions on the calculator. So let's start off with sine of x and graph that. We don't get a whole lot on our standard square, and if you remember why, because sine oscillates between 1 and negative 1, and this is a 10 by 10 graph. So if we zoom in and go to 7, that will give us our trigonometry. And there we have a nice sine curve. If we look back at our problem, we were looking at x squared equals cosecant. We don't have a button for cosecant, but cosecant is 1 over sine. So we can graph that 1 divided by sine x, close the parentheses, and graph it. And now we can see a nice cosecant function with when sine is 1, cosecant is 1. When sine is 0, we have our asymptotes for the cosecant function. Now let's go back. We'll take off the sine function. We don't need that one in our problem. I just wanted to put that on to show you. Let's put in x squared. And graph that. So we get our nice cosecant function, but where's our x squared? Let's look at our window, and we have our x minimum is negative 352, and our x maximum is 352 with a scale of 90. So let's see what happens if we go back to our standard on this one. There's our x squared. And then we just get little pieces of the cosecant. We can see up here it's not too far before they intersect, and what we're looking for is where x squared equals the cosecant of x, and that's where they will intersect. So if this is our standard, that is our y is 10, so we just need to raise up our y a little bit more. So let's take our y maximum up to 50. There's our x squared. There's our little bits of the cosecant. And now we have our intersection. So we can find our intersection. We want the first curve is y equals x squared. And our second curve is the 1 over sine x, or the cosecant. And we can see they intersect at where x is 3 and the y is 14. So we want the smallest value of x. The thing about dealing with the cosecant is a periodic function. So there will be many answers, many points where x squared will be equal to cosecant x, and that's why it's asking for the smallest possible value of x. And now, just for fun, a little equation for you. See you in class.